Hello and welcome to the second half of our video covering the Vickers Wellington, Britain's most mass-produced bomber. If you haven't seen the first half, I highly recommend you go and check it out. And if you already have, I apologise because this video is about a month late. But as many of you know, I caught COVID and that sort of threw a spanner in the proverbial works. But part 2 is here now at last, so let's get right into it. Last time we looked at the development and operational history of the Vickers Wellington as it was originally envisioned, that being a long-range medium bomber. But although it is primarily remembered as such, the Wellington also distinguished itself in a multitude of other roles, some of which were remarkably different from what it was originally designed for. A majority of these other Wellingtons served with Coastal Command, so I think starting with these makes the most sense. And what better way to start than with the weirdest Wellington of them all? In the opening months of the Second World War, British shipping losses from sea mines began to rapidly escalate. Alarmingly, many of these ships had been sunk in waters that had been recently swept and declared clear of mines, only to be sunk anyway. The cause of this loss was a new type of magnetic sea mine, one that was being rapidly laid in the coastal waters surrounding the major ports of southeast England. These were deadly and effective weapons, which, unlike traditional contact mines, didn't need to float on the water's surface to be effective. They could simply lie in wait on the seabed of shallow waters, being practically undetectable whilst doing so. Eventually, a ship would pass overhead, and the magnetic field of its hull triggered the detonator, upon which the presence of the mine would become suddenly and violently obvious. Their effectiveness quickly pushed shipping losses to a critical level, and top priority was placed on finding a way to neutralize this threat as quickly as possible. Fortuitously, a solution arrived earlier than anyone could predict. In a rare moment of early war good fortune, an intact mine was recovered from the mudflats of the Thames estuary, having been laid at low tide. It was subsequently disarmed, disassembled, and analysed, and from this came two solutions to the problem. The first was a passive method of neutralising the mine's effectiveness, a process called degaussing, which nullified the magnetic attraction of the ship's hull. But perfecting this method, and then employing it aboard all relevant vessels, would take some time. Until then, an immediate and more aggressive solution was called for. Attempts were first made using ships fitted with electromagnetic generators to detonate the mines from a distance, but the mines proved to be very good at their intended jobs, and these ships were seriously damaged. It was then suggested that a low-flying aircraft could be used to trigger the mines remotely instead. Now, an aircraft possessed nothing like the same magnetic field as a several thousand-ton merchant ship, but with the right equipment, this field could be generated, and thus the detonator of the magnetic mine could be tricked. For this, Vickers was approached to modify a Wellington and fit it out with the required equipment. This consisted of a large aluminium coil, housed inside a giant ring of balsa wood, and an electric generator, the current of which, running through the coil, would generate the magnetic field. The result was a Wellington that was quickly referred to as the Flying Doughnut, the 51-foot diameter ring being somewhat of a dominating feature. Within this ring was an aluminium coil, and this was connected to a 35-kilowatt Maudsley generator, which itself was driven by a Ford V8 engine. When the V8 was turned on, it would drive the generator, which would send an electric current through the coil, which would generate a magnetic field and trigger the mine. Work progressed on this strange-looking prototype throughout December of 1939, and amid rising losses of Allied shipping, permission was quickly given to convert another 3 Wellingtons to this configuration by the end of the year. Together, these were known as the Vickers Type 418, and given the codename Directional Wireless Installation, or DWI for short. The first of these was complete by mid-December, and it was delivered to No. 1 General Reconnaissance Unit, which had been specially formed to operate these highly experimental aircraft. With the ring installed, but without the aluminium coil, it flew for the first time on the 21st of December. It handled remarkably well, and the anticipated aerodynamic problems of this design proved less than originally feared. Indeed, it actually took off more easily than a regular Wellington due to the angle of attack of the ring providing a level of additional lift. This was traded off during landing, where the same ring now provided an equal amount of extra drag, but it wasn't enough to be dangerous, and following these flight trials, the aluminium coil was installed for practical testing on magnetic mines. The first of these tests were carried out on the magnetic trigger of a defused mine, and these were done at the experimental airfield at Moscombe Down. These provided encouraging results, but they also highlighted several factors that had to be considered before practical results with real mines could be realized. Firstly, there was the consideration of tidal depth, which affected how far the magnetic field would have to reach to trigger the mine, something that was compounded by the fact that the magnetic fields generated thus far were felt to be a little on the weak side. Secondly, there was the consideration of altitude, or how low could the aircraft safely operate at before it ran the risk of being damaged by the very mines it was meant to destroy. Eventually, an altitude range of 35 to 60 feet was settled upon. Thirdly, there was the consideration of speed. The aircraft had to be slow enough that the magnetic field peaked around the mine for long enough to trigger it, but also fast enough to not be over the mine when said event happened, a tricky calculation. The complexity of the problem was highlighted in an incident that also further confirmed the strength of the Wellington airframe. The first successful detonation of a mine, in live trials, happened on the 8th of January 1940, but during the second test on the 13th, the aircraft strayed too low at the critical moment, going well below 35 feet. Once again, the mine was successfully detonated, but the proximity subjected the Wellington to well over 10 Gs of sudden and violent acceleration. Following this, the crew made a hasty retreat to their airfield, but despite themselves being quite rattled, an examination of the Wellington showed the airframe hadn't been compromised. In fact, it was cleared to fly again the very next day. Thankfully, this was the only major close call experienced by the Wellingtons of No. 1 GRU, and through perseverance, the art of effectively and safely detonating these magnetic mines was perfected throughout the rest of the month. By mid-February, 2 DWIs had already completed several minesweeping operations, and they were then joined by a third, improved version, which would become the template for the DWI Mark II. Thus far, the rate of mine destruction had been described as steady rather than spectacular, a consequence of limited power. This had already been realized before the first DWIs were even operational, and the third and fourth prototypes had been held back for modification. The Ford V8 was replaced by a more powerful de Havilland Gypsy engine, and this allowed the Maudsley generator to be replaced by a more powerful and more efficient model built by English Electric. The end result was an increase in electrical power from 35 to 95 kilowatts, a 50% increase in the magnetic field, and a weight reduction of 1,000 pounds owing to a simplified installation system. With these improved models in company, the DWIs of No. 1 GRU made numerous successful sweeps throughout March and April of 1940. Sometimes these were done with individual aircraft, but often they were done as a coordinated group to improve the effectiveness of the sweep. This was particularly common in areas of coastal water where there was a lot of sea traffic, which thus made them a bigger target. Though these Wellingtons were mostly without escort on these missions, a perilous situation given their complete lack of defensive armament, they had not yet come under attack by intruding Luftwaffe patrols. In fact, the first time they were fired upon was a case of misidentification. They had been sent to sweep the local waters ahead of the planned evacuation of the Dutch royal family by the Royal Navy, and the local air defences, understandably a little trigger-happy owing to the invading Germans, looked into the sky, saw what appeared to be a bomber adorned with a glorified hula hoop, assumed it was some sort of German wonder weapon, and promptly opened fire. Thankfully, no damage occurred. During their time in the coastal waters around southern England and in the Channel, the crews of these ringed Wellingtons found them to be, on the whole, easy to handle. They praised the Wellingtons' well-harmonized controls, no doubt a comfort when you're 40 feet above mine-infested waters, and they reported minimal aerodynamic effects on the handling when the mines detonated, providing they weren't too low, of course. Takeoff was still easy, and landing was still somewhat sketchy, with the crew essentially being committed once they were below 500 feet on their final approach. On the whole, they were well liked, and they provided a startling sight for the coastal inhabitants and the various ships' crews that saw them skimming across the water at almost 200 miles an hour. But owing to the rapid development of degaussing equipment aboard British vessels, the need for these aircraft around British coastal waters was relatively short-lived. They did, however, serve for longer in the Mediterranean theatre. In late May 1940, GRU No. 1 was transferred to Egypt, as the involvement of Italy in the war was a matter of when, not if, and after Italy's declaration of war on the 10th of June, minesweeping operations immediately began the following day. Initially, 5 DWIs operated in this area, but this number was increased by a handful of Wellingtons that were converted to the type in Egypt, courtesy of supplies sent over from Britain. Their first operational sweeps covered the coastal approaches to Alexandria, followed in the next few days by the Suez Canal and its ports, all of which being of vital importance. This was a task that the Wellingtons were to continue for the entirety of the African campaign, following the fighting back and forth along the coastline, and clearing ports of mines laid down by both sides when called for. The last known DWIs in use in this theatre are thought to be single examples operated by 162 Squadron, a radio countermeasures unit, which still had at least one on strength in Africa as late as 1944. Though the career of the DWI Wellington was brief, the other examples operated by Coastal Command enjoyed a much broader and longer service life. As the need for DWIs waned in the autumn of 1940, Coastal Command, in close liaison with the Admiralty, was urgently preoccupied with another problem, one that had been haunting them from the beginning. How did they deal with the U-boats that threatened Britain's maritime supply lines? Part of the answer was already there, as in August of 1940 they had improved their capacity to destroy U-boats thanks to the addition of around 700 Mark VII depth charges. But finding a satisfactory way of locating said U-boats to then use said depth charges on was proving to be a challenge. This would change with the Wellington GR Mark VIII. By 1941, airborne radar, particularly air-to-surface vessel radar, or ASV, was now becoming available in quantity. It was shaping up to be a promising tool against enemy surface vessels, and there were great hopes that it could also be used against U-boats as well, but it had a limitation. U-boats rarely surfaced during the day, for obvious reasons, so most of the time the radar would have to be used at night. But due to the surface echoes of the water, a surfaced U-boat would drop off radar at a distance of approximately 1 mile. This would force the aircraft to shoot off flares to illuminate the area, which would then spook the U-boat into evasive maneuvers, usually culminating in a crash dive, and the chase would be over. Coastal Command's AOC&C, Air Chief Marshal Sir Frederick Bowhill, cast around his broad command in the hopes of finding a bright mind that might solve this problem. Funnily enough, it would be a member of his own headquarters staff that would provide the solution, an administrative officer, Squadron Leader Humphrey de Verd Lee. He envisioned, and then formally proposed, the fitting of a powerful searchlight to an anti-submarine aircraft that was equipped with ASV. His plan was to home in on the sub's location using the radar in complete darkness until the final mile where it dropped off scope. The searchlight would then be switched on, illuminating that final mile of sea and showing the U-boat stark against the water. As this illumination would be instant, unlike the gradual burn of a flare, he believed the aircraft would be able to bear down on the U-boat before the crew had time to react. His proposal received a certain amount of skepticism from the Royal Aircraft Establishment at Farnborough, but Lee had the full support of his superior, Sir Frederick, and he was assigned to work on the project full-time. A redundant DWI Wellington was selected as the testbed. Its giant ring was removed, but the electric generator was left in place to power both the radar and the searchlight. Initially, Lee wanted to use the 90cm searchlight operated by the Army, but this proved to be too bulky and it generated too much heat, so he settled for the smaller but still very powerful 60cm unit most commonly used by the Navy. In a stroke of luck, this smaller unit fit perfectly into the confines of a converted Fraser-Nash turret, which made it much easier to operate. This also meant that the searchlight turret could be easily installed in the underbelly, it being lowered through the hole which had been originally designed for the Mark I Wellington's dustbin turret. During its development, it was called the DWI Mark III to hide its real purpose. As work progressed, Lee made changes to improve its performance, replacing the bulky generator with an array of batteries, and upgrading to the ASV Mark II radar. He then had the privilege of witnessing his success firsthand, being aboard the Wellington when Royal Navy submarine H-31 was tracked by its radar and then illuminated by its searchlight. After the exercise, naval officers aboard the submarine testified that the bomber was not detected until the searchlight was switched on, at which point there was almost no time for them to avoid any attack. This fully confirmed Lee's design, and the aircraft was ordered into immediate production as the Wellington GR Mark VIII. No. 172 Squadron was formed as the first official unit to operate the Mark VIII, and on their very first mission they proved its effectiveness wasn't just the lucky fluke of a well-executed exercise. Flying a patrol off the coast of Spain on the night of the 2nd to 3rd of June 1942, they successfully located, tracked, engaged, and damaged the Italian submarine Luigi Torelli. A few days later, on the 5th of June, they scored their first kill, sinking U-502 in the Bay of Biscay. Although the number of successes was destined to be small, the effect on German naval morale was significant, and until the development of mobile radar units, the U-boats had almost no protection against this new weapon system. A drop in Allied shipping losses from 600,000 to 200,000 tons per month in 1942 was directly attributed to the combined use of this system aboard Vickers Wellingtons and B-24 Liberators. Though the Leigh Light Mark 8 saw action in the Channel, the North Sea, the Bay of Biscay, and the Atlantic, another version saw concentrated use in the Mediterranean. Developed in parallel with the Leigh Light Wellington, a daytime variant had been designed for the purpose of hunting enemy shipping, a critically important resource for the campaigns in Africa. Though it was equipped with 2 torpedoes in place of depth charges, and fitted with gun turrets in the nose and tail, this was still classified as the GR Mark 8, despite being converted for a totally different purpose. Based on the island of Malta, these Wellingtons would be kept perpetually busy throughout the majority of 1942, particularly around the Battle of El Alamein, but their use would continue in this theatre throughout the entirety of the war. The reason why both of these fairly different aircraft were lumped under the same designation was because they were more of an impromptu allocation of hastily converted equipment, rather than a dedicated series that had been designed from the outset. But this would be corrected with the next series of Coastal Command Wellingtons. Encouraged by Coastal Command's experience with the GR Mark 8 thus far, both as a torpedo bomber and as a submarine hunter, the RAF and Vickers worked together to develop updated versions of both. These were developed from the newly arrived Wellington Mark 10, and this time they were built specifically for Coastal Command use from the outset. This led to the production of a quartet of Coastal Command, or Webfoot Wellingtons, and the first of these was the GR Mark 11, an updated torpedo bomber. Like the GR Mark 8, this came equipped with the ASV Mark II radar, which featured 4 large aerials that were mounted along the spine of the fuselage, as well as 2 rows of T aerials mounted along the side. Other than this change, the Mark 11 was essentially the same as the Mark 10 bomber, and this was for good reason. German merchant vessels were now sailing in heavily protected convoys, and these often included merchantmen modified as flagships. Because of this, the nose turret was kept on the Mark 11 to provide some modicum of forward firepower, to try and dissuade enemy gunners during a torpedo attack. In total, 180 of these Mark 11s would be produced, but that would be a small number in comparison to their successor, the Mark 13. This was essentially similar to the Mark 11, but it had one major difference, and that was the power plant. From the outset, there had been complaints about a lack of power, both with the GR Mark 8 and the Mark 11 and the Mark 12, the latter I will come to in a moment. The provision of radar equipment and the bulky generators or batteries required to run them added up to a lot of weight, almost 2 tons in fact, which was the equivalent of a full bomb load for an early Wellington. Not only did this make them a bit on the slow side, but it also meant that they could not fly on just one engine, a terrifying prospect on any occasion, but even more so when you're flying hundreds of miles over open sea. To correct this, the Mark 13 was powered by a pair of 1735 horsepower Bristol Hercules 17s, which were the highest rated engines to be equipped on a wartime Wellington. Provision was also made to carry the ASV Mark III radar on some models, but this required a redesign of the nose, and it was mostly reserved for use aboard the anti-submarine version. In total, 844 of the Mark 13 would be built, and they would see operations in the Mediterranean, the Channel, and the North Sea. The second half of the Coastal Command Quartet was dedicated to the anti-submarine Wellingtons. Deeply impressed with the Leigh Light-equipped Mark 8, Coastal Command was eager for more, and this led to the GR Mark 12. This came with the ASV Mark III, which had been fitted to some of the aforementioned Mark 13s. This new radar system did away with the external aerials, with all of the equipment being installed in a nose-mounted teardrop fairing, and the upper section covered by a clear canopy. But as mentioned before with the Mark 11, some sort of forward-firing weaponry was required, as the U-boats had also taken to fitting themselves with various anti-aircraft weaponry and were readily engaging the very aircraft sent to destroy them. In place of the nose turret, which couldn't be reinstalled due to the radar, a pair of machine guns on flexible mounts were fitted to the clear canopy of the upper nose. Standard battle practice was to blind the gunners on the U-boat with a liberal blasting from the Leigh Light, while the nose gunner made use of said light to better sight his guns. The U-boat Tactica remaining on the surface, and duking it out with Allied aircraft, inevitably led to the loss of some Wellingtons in one-on-one fights. One remedy to this was for a Wellington to shadow its target whilst calling up support, and then a coordinated attack could be used to overwhelm the enemy. Eventually, this forced the U-boats to switch back to the tactic of crash diving to evade attacks, something which itself became self-defeating with the deployment of the Mark 24 homing torpedo. As with the Mark 13 being an improved version of the Mark 11, the Mark 14 was an improved version of the Mark 12. Again, this featured the much more powerful Hercules 17 engine, and again, these were built in much greater numbers, with 841 being produced in total. These aircraft in particular saw a busy spell of activity in the weeks leading up to, and immediately after, the Allied landings at Normandy. Here, they flew a great number of sorties to destroy, delay, or otherwise prevent enemy submarines from sinking the vast convoys that supplied the beachheads. Owing to their wide use, Coastal Command Wellingtons gradually earned a multitude of nicknames for one reason or another. Many in the RAF called them Webfoot Wimpies. Wellingtons equipped with the ASV Mark II were called Sticklebacks, owing to their spine-like aerials, and Coastal Command crews often referred to their aircraft as Goofingtons rather than Wellingtons, a vocabulary that was then expanded to include Fishingtons when they started to carry torpedoes. Though never designed with these roles in mind, Wellingtons put in a lot of work with Coastal Command, and some of their more interesting exploits on various missions, some of which are rather strange indeed, will be covered in a future video on specific Coastal Command operations, so keep an eye out for that in the semi-distant future. Moving on from Coastal Command Wellingtons, we come to one that, ironically, looked like it operated with Coastal Command. But although it had the appearance of a Wellington crossbred with a humpback whale, its design was about as far away from the sea as you could get, as it was built for high-altitude flying. One of the biggest challenges faced by Bomber Command was how to get through the lines of German air defences without taking heavy losses. In the earlier years of the war, the Kammhuber line was the main obstacle to overcome, and as this line grew in length, depth, and effectiveness, it became increasingly obvious that the German defences would have to be penetrated rather than circumvented. This is where the Mark V and VI Wellingtons come in. As early as 1938, it had been theorised that bombers flying at the highest altitude possible would have the greatest chance of survival in a hypothetical war with Germany. They would avoid the worst of the flak batteries, and night fighters were not yet the effective, radar-equipped nightmares that would be seen in later years. The idea was appealing enough that Vickers proposed the development of two prototype high-altitude Wellingtons. One would be equipped with the Bristol Hercules engines, and the other with Rolls-Royce Merlins. The proposal was quickly approved, and both prototypes were ordered in May of 1939, with the Hercules model developed as the Wellington Mark V and the Merlin model as the Mark VI. The Mark V flew first, taking off for the first time in September of 1940. This first model was powered by a 1425 horsepower Hercules III, and later on a second model was built with the more powerful 1600 horsepower Hercules VII. Its whale-like upper nose, fed flush with the fuselage, became a hallmark of this design, and it got this shape from the cylindrical pressurized cabin that would house the crew and keep them safe at high altitude. This crew was much smaller than a standard Wellington, due to a lack of defensive guns, and it consisted of just 3 men, a pilot, a radio operator, and a navigator, who also served as bomb aimer. This cabin was not exactly roomy, and with nothing but a bubble canopy to see out of, the visibility for the pilot for takeoff and landing was not ideal. The canopy was slightly offset to port to help with this, but it still proved tricky to land and taxi on the ground, with many a near miss during the testing phase. Claustrophobic elements aside, it would at least keep the crew alive, with a cabin pressure set at a bearable 10,000 feet, compared to the estimated operational altitude of 36,000 feet. Despite still being in the testing phase, the need for a high-altitude bomber had grown following the fall of France, and an order was placed for 132 high-altitude Wellingtons, with the production to be split between the Mark V and the Mark VI. Following its initial test flights, the more important high-altitude test flights began with the Mark V, and without trying to sound like a broken record when it comes to highly experimental aircraft, this is where the problems began. Flying at high altitude brought its own unique set of challenges, ones that quickly made life incredibly difficult for the Wellington. Some of these challenges were minor, trifling things, but others were downright alarming. During extended periods at high altitude, the pilots had the diverting experience of watching his canopy completely ice up, thus reducing all visibility, and this was believed to be caused by high humidity in the cabin. Other scenarios not to be associated with happiness or low stress levels included the complete seizing of control surfaces owing to frozen grease, and one incident involving an engine leak led to the propeller sending frozen bullets of engine oil into the fuselage and cabin, which threatened a violent decompression. While many of these problems were eventually addressed, the unreliability of the Hercules engine at high altitude was not, and in the end it proved so troublesome that the Mark V was cancelled in favour of the Mark VI. The Mark VI carried a slightly larger crew of 4, a pilot, navigator, radio operator, and a dedicated bomb aimer. These aircraft also had their wingspan extended by 12 feet to improve high-altitude performance, which also increased the maximum altitude to 40,000 feet. Unfortunately, the problems that plagued the Mark V also came to haunt the Mark VI, with the prototype suffering from problems with ice accumulation, frozen lubricants, and a want of heat retention. By the time testing of the Mark VI prototypes was concluding, the need for high-altitude bombers was being reassessed, partly due to shifting changes in air staff policy, and partly due to the many problems encountered thus far. As a result of this, not a huge number of these bulbous high-altitude Wellingtons were built. Of the original order for 132, only 67 were ever completed. 3 were the Mark V prototypes, 28 were Mark Vs taken from production line and converted to Mark VI standard, and the rest were built as Mark VIs from the outset. By the time that the Mark VI was rolling out of the factory, the idea of using the Wellington as a high-altitude bomber had been dropped entirely. Unwilling to view them as a complete loss, Vickers and the RAF repurposed the aircraft for use as trainers for, or operators of, the blind target marking device codenamed Oboe. For this, the Wellingtons were redesignated as the Mark VI-G, and they were put into service in the autumn of 1942. In this role, they provided extremely precise results for Bomber Command's pathfinding force, particularly when used as target markers for the winter raids of 1942 through to 1943. But their use in this role was doomed from the start. The de Havilland Mosquito was already entering operational service, and it was better at this role in every way. It was lighter, faster, could climb better, and it could reach an altitude that almost equaled the Wellington without the need for a pressurized cabin. Once again, the high-altitude Wellingtons were without a purpose, and this time it was the end of them. Converting the aircraft back to normal Wellingtons would have been prohibitively expensive, and besides, the Wellington was now being replaced by larger bombers anyway, and so the entirety of these strange-looking aircraft were gradually scrapped between 1943 and 1945. Though mostly remembered for its offensive roles, the Wellington also found itself useful in non-combat duties as well. The roominess of its fuselage, the general sturdiness of the geodetic airframe, and its long range led to considerations for the Wellington to be used as both a civil and a military transport. These considerations were made before the outbreak of war, and were subsequently shelved as the need for pure bombers took priority. But eventually the idea of a Wellington transport was revived in 1941. At the start of the year, Vickers were ordered to convert a number of older Wellingtons into troop and equipment transports to be sent over to Africa. Since all this required was essentially the removal of all combat and ancillary equipment, most of these conversions were done locally as the need for transports arose. Because of this, the exact number of Wellingtons converted for use in Africa is unknown. As a transport, they could carry up to 18 fully equipped soldiers, or their equivalent weight in supplies, over a distance of approximately 2,000 miles, or 3,200 kilometers. These aircraft were unarmed, but as they often travelled through areas that didn't enjoy total air superiority, this weakness was disguised. Most commonly, this was done by painting on fake turrets and sticking on a couple of broomstick handles in place of the machine guns. The Wellingtons performed well in this new role, and this led to multiple conversions in every theatre they served in. Some were used as troop transports, but many performed a variety of other duties as well. Some served as ambulances, some as equipment transports, and some, particularly in India, were used for training paratroopers. Eventually, all of these various conversions, usually from Mark 1As or Mark 1Cs, were ratified into an official designation, either being listed as the Mark 15 or Mark 16 respectively. Additionally, the RAF was ordered to provide 4 Wellingtons to the British Overseas Airway Corporation in 1942, and this collection was unofficially known as the Wimpy Airline. Initially, these were flown by contracted airline captains, but this posed legal difficulties as the aircraft were not civil registered, nor did they come with an official certificate of airworthiness, and so they were handed over to a dozen or so ex-Wellington second pilots. This miniature air fleet was operated for approximately 9 months, and although they were a bit rough and slow compared to some of the other sleeker transports of the BOAC, they got the job done, just. These Wellingtons were earlier models that didn't benefit from the more powerful engines that were installed on the Mark III and the Mark X. As such, there were quite a few near misses. Though they managed to not actually break anything, and maintained a 100% safety record, a former pilot remembered observing one of these Wellingtons, which had been seriously misloaded, make multiple attempts to get down to its airfield without either stalling, overshooting, or slamming into the barriers due to a crosswind. After a landing that would put even Ryanair to shame, the pilot apparently got out, bone-white and visibly shaken and trembling, only to be congratulated by one of the passengers, who warmly said to him, "Thank you, Captain, for a delightful flight." Another vital, non-combat role of the Wellington was that of a trainer. Though it remained in operational service with Coastal Command and in the Far East until the end of the war, on the home front it had been phased out as a frontline weapon by mid-1943. By this point, the Mark X Wellington, considered the peak of its design, was available in large numbers, and many believed it was the perfect candidate for an operational trainer. A multitude of these Mark X Wellingtons were subsequently converted into the T Mark X. Occasionally, they were used to ease bomber crews into operational service by flying leaflet raids over Europe, but they were mostly used for training newer crews up to a standard where they would then graduate onto the newer, larger 4-engine bombers. This was a role they filled throughout the rest of the war, and for many years afterwards. Along with the T Mark X, there were 3 other variants of training Wellingtons. The T Mark 17 was used for training in the operation of air interception radar. The T Mark 18 was used to train radio operators and navigators. And the T Mark 19 was an improved version of the Mark X, with more powerful engines and modernized equipment. These saw extensive use after the war, and were still in service as late as 1953. Along with the various marks of Wellingtons that saw service before, during, and after the Second World War, there are also some one-off examples that deserve an honourable mention. The first is Wellington L4250. Following its use as the prototype for the Rolls-Royce-powered Mark II series, it was selected at the end of 1938 to be a testbed for the installation of so-called ultra-heavy armament. This was done to gather data to assist with the development of aircraft that were to be designed to specification B1/39. This had initially called for a heavy bomber that mounted a series of 20mm cannons for defense, but then somebody had the crystallizing idea of fitting 40mm cannons instead. Installation on the Wellington was limited to a single gun mounted in the dorsal position, as the idea of adding more was considered both laughable and suicidal. As it turned out, adding just one of these heavy guns was enough to cause all sorts of problems. Not only was the recoil and rate of fire a concern, but it caused severe and dangerous vibrations due to turbulence, and it played havoc with the airflow over the tail fin. To try and fix the perilous instability, the tail was reshaped to a twin-tail configuration, which brought the tail fins in line with the slipstream of the engines. In this guise, the testing continued, but the stability of the aircraft was still nowhere near acceptable. A new streamlined housing for the turret was tested, but this had minimal effect, and it didn't address the biggest problem, which was the constant change in roll trim every time the gun was traversed more than a few degrees. After this, a second Mark II Wellington was used to test a different arrangement, this time with the cannon mounted in the nose. But this did not progress very far, as the original specification that had prompted the experiment had been cancelled, which was probably for the best. Other Wellingtons played more successful roles in the testing of other weapons and devices as the war progressed. One became the first aircraft to test the famous bouncing bomb developed by Barnes-Wallis, which would go on to fame as the weapon used in Operation Chastise, aka the Dambuster Raid. Another trio of Wellingtons played a vital role in the practical development of the early jet engine, specifically the power plants developed by Frank Whittle. In each case, a Whittle engine was mounted in the tail section of a Wellington, and these performed practical tests from 1942 all the way through to 1945. Their use as various test beds, transports, minesweepers, submarine hunters, ambulances, and other roles far outside their original design specification speaks volumes to the versatility of the Wellington. An aircraft designed in the mid-1930s would usually find itself obsolete and replaced by the start of the Second World War, but this was one of the rare exceptions. Not only did it serve throughout the war, but it even soldiered on in various places well into the 1950s, not only with Britain, but with other countries such as France and Greece. Its success spawned a series of derivatives, one of which being the Vickers Viking, and an example of this aircraft would go on to become the world's first purely jet-powered transport in 1948. And so an aircraft built from the principles taken out of airship design would eventually go on to become one of the pioneers of the jet age. And if that isn't an impressive legacy, then I don't know what is. As always, thank you all so much for watching, and a big thank you of course to the patrons, with a special shout out to the Wing Commander tier patrons, and to the newest members of this illustrious rank being Steve S. and Jigglebone Jones. Thank you all so much, and thank you all for your patience in waiting for this video to come out. Hopefully this sort of delay doesn't happen again. I don't really feel like having the plague twice, to be honest. And apologise if the narration is a little bit off in this video. They've been doing backburning, which is kind of like pre-done bushfires in my area, and it has really triggered my asthma, which is making it really hard to do long videos. But I was determined to get this done. So thank you all so much for putting up with me today, and I will catch you all next time. Goodbye.